Okay, we are on page 14 today, and we're going to talk about solving by factoring. We've factored in our last unit as a way to find x-intercepts. So we're going to see factoring again now as a way to find solutions or zeros for our functions. Okay, so let's start up at the very top with just a review of what we mean when we talk about factoring. Again, we're on page 14. So the first one here says list the possible integer values for a and b so that a times b equals 24. What I'm asking you for here are factors of 24. So what times what would give me 24? 12 times 2, 6 times 4, 8 times 3, 24 times 1. This is half the list. What would be the other half? The negatives, right? So negative 12 times negative 2, negative 6 times negative 4, negative 8 times negative 3, and negative 24 times negative 1, right? Since a negative times a negative gives me a positive, I could be multiplying two positive numbers, or I could be multiplying two negative numbers. And those would be my factors, my integer factors of 24. Now, for the second part here, I want integer values again, so positive or negative whole numbers, so that when I multiply them, I get 0. So what could I multiply together and get 0? 0 times 1, right? 0 times 2, 0 times negative 17, 0 times 104, right? 0 times anything. A lot of options here. What we're going to use today is something called the zero product property. So that's actually what we're going to talk about first. If we've got two numbers and they multiply together to give me 0, or if I've got a whole big list of numbers that multiply together to give me 0, then either A has to be 0, B has to be 0, or they're both 0. If I multiply some stuff and I get 0, at least one of those things that I multiplied has to be 0. Does that make sense? So if I did a really simple version of this, if I said, hey, I have 2 times x and it equals 0, that means I did 2 times something and I got 0. What's the something have to be? If I multiplied 2 by a number and got 0, the number has to be 0, right? That's the zero product property. That's the big idea that we use when we're solving by factoring, okay? The idea that if I multiplied these things together and got 0, one or the other or both had to be 0. That's how we find our solutions when we're factoring. So if I jump down to my problems here, I've already got factored form for this first example. And what I'm seeing is this times this equals 0. Well, that means either this part is 0 or this part is 0. So what we're going to do is find the x's that would make each of these 0, okay? This is just like when we were looking for x-intercepts by factoring, okay? So our big goal when we solve by factoring is to set each factor equal to 0 and solve for x. Once I've got factored form, I set each factor equal to 0 and solve for x. And again, for this top section, we're already in factored form, so the hard work is done for us. So I'm just going to take each factor and set it equal to 0. So 3x plus 6 equals 0, and 2x plus 5 equals 0. And then we'll solve for x. So if I solve for x in this first factor, I'm going to move that 6 to the other side, then divide both sides by 3, and I get x to be negative 2. Over here, I'm going to start by moving that 5 to the other side. I get 2x equals negative 5. Divide both sides by 2, and I get x to be negative 5 over 2. There are my two solutions. If we graph this, those would also be our x-intercepts. I want you to try the next example. already have factor form. So you're just setting each factor equal to 0 and solving for x. Okay, let's take a look. So we've got 2x minus 1 equals 0, 3x minus 2 equals 0, and x minus 1 equals 0. Again, our goal is to get x by itself. So my first solution is x equals 1/2. My second solution is x equals 2/3. And my last solution is x equals 1. Questions there? Okay. The last problem in this chunk has some not really tricky stuff, but things that I've seen mistakes on when we were talking about x-intercepts. We have this x in the front here. When we had a function like this and I asked you for x-intercepts in our last unit, I had some people sort of skip over that x. Remember, that is important. That's a factor here. So as I'm looking at solving, I need to make sure I also set that equal to 0. And the nice thing about just having plain old x is there's no work to get that solution, right? I set it equal to 0 and that's it, x equals 0. Over here, I've got x minus 7 squared. So I'm setting x minus 7 equal to 0. Do I need to set another x minus 7 equal to 0? Am I going to find a new solution if I do that? No, it's going to be the same as what I get here. But one thing I want you to keep in mind is when we start talking about fundamental theorem of algebra, how many zeros should I have? How many zeros do I have? That this one's going to count for 2 because of that quadratic behavior, okay? So I've got a solution at x equals 0, and then a solution at 7. And just remember that this one counts for 2 because of that multiplicity. Questions for me so far? Okay, so we started with some problems that were already in factored form for us. Now we're going to look at a couple that we need to factor. So we're going to do some factoring review as we work through our last couple of problems together today. So if we hop down to the bottom section on page 14, just as a reminder, when I am factoring, I need everything on the same side set equal to 0. So as I look at a couple of the problems down here in that bottom line, I'm going to have to do some rearranging before we can factor. If you are going to factor everything on the same side equal to 0, okay? And make sure you have standard form. For my first example, I have everything on the same side equal to 0, so I can start factoring here. What's the first thing I want to do anytime I'm factoring? Yeah, I have a GCF here. Look to see if I have a GCF, and you said I have a GCF of 2x. So I'm going to go ahead and pull that out. That would leave me with 2x squared minus 11x minus 21. And then I'm going to use AC method here since I've got a lead coefficient that's not 1. So that would be 2 times negative 21. That gives me negative 42. And then I want factors of negative 42 that add to negative 11. Okay. For a problem like this, I would expect you probably need to make a list, right? We don't look at factors of negative 42 all that often, so I might need to make a list. So this could be 1 times 42, and again, one of them would need to be negative. We could do 2 times 21, and again, one of them has to be negative. 3 times 14, and this one actually would add to negative 11. So I'm going to use 3 and negative 14. So for AC method, I keep that first term the same, but I'm going to split up the middle term using the factors I've chosen. So plus 3x minus 14x minus 21. And then we'll use grouping here. GCF for my first group is x. That leaves me with 2x plus 3. The GCF for my next group would be 7. And since my group starts with a negative, I'm going to use negative 7 as my GCF. That would leave me with 2x plus 3 when I factor negative 7 out of both of these terms. Remember, when you factor by grouping, your stuff in parentheses should always be the same. So we pull that out as a GCF now. And left over, we have x minus 7. Now, don't forget, we already factored out a 2x. So that needs to hang out in front here. And now I have my factored form. Once we have our factored form, we can find our solutions. So I'm going to set each of these, I'm going to turn my paper just a little bit, each of these equal to 0 to solve. So 2x set equal to 0 gives me a solution of 0. 2x plus 3 set equal to 0. And solve for x. Gives me a solution of negative 3 over 2. And then finally, x minus 7 set equal to 0 gives me a solution of 7. So I get x equals 0, x equals negative 3 over 2, and x equals 7. So here was the new part where we're solving, but all the factoring stuff we've done before. Let's take a look at our next example. What's our first step to factor this? We have a GCF of 15x. So that would leave me with x squared, and then 16 divided by 15 would be 4, so minus 4. So 15x times x squared minus 4. X squared minus 4 we can keep factoring, right? We've got a difference of squares here. Even degree, perfect square, subtraction, difference of squares. So this is where we asked ourselves, what did I square to get each part? So what would I square to get x squared? X. What would I square to get 4? 2. So this would be x plus 2 times x minus 2. And then don't forget your 15x in front. And now I can finish solving by setting each factor equal to 15x equal to 0. So my solutions would be 0, negative 2, and positive 2. Questions for me so far? Okay. Now, if we take a look at this bottom row, my third example here has my polynomial split up across both sides of the equal sign. If I want to solve by factoring, I have to have everything on the same side set equal to 0. I like to keep the x squared term, or if it's x cubed, whatever the thing is with my biggest exponent, I like to keep that positive. So I'm going to move this stuff over here. That's just my personal preference. If your lead coefficient is negative, then you're probably going to have to start by factoring out a -1. So maybe a little more work now, but it saves me a step later. So I'm going to move this stuff over here. So I'm going to add 3x to both sides and subtract 18. So I get x squared plus 3x minus 18 equals 0. So I've just rearranged it. I haven't combined anything because I don't have any like terms. All I did was rearrange. And now if you want to use AC method, you can, but we can use that sort of guess and check strategy here since our least coefficient is just 1. All I'm going to look for are factors of negative 18 that add to 3. Factors of negative 18 that add to 3. What factors do I want? 6 and 3, and one of them's got to be negative. So which one should be negative? The 3. Yep. So this would be x plus 6 times x minus 3 equals 0. And then set each factor equal to 0 and solve. So we would get x equals negative 6 and x equals 3 for our solutions there. I want you guys to try this last example. Remember, before you factor, you need everything on the same side set equal to 0. My first step is going to be to move this 5 to the other side. And now I can factor this. Remember, I need everything on the same side set equal to 0. Since my least coefficient is just 1, if you want to use the AC method, you can, but we can use guess and check like we did for our last example. Either way, I'm going to start by looking for factors of 10 that add to 7. What do I want here? 5 and 2. So my final factored form will be x plus 5 times x plus 2. And my solutions then will be x equals negative 5 and x equals negative 2. Questions for me? Okay, so you've seen factoring before. That's not new. We spent a lot of time on that in our last unit. If you thought it was going to go away, sorry. It's going to stick around. We're going to see it next semester too. So this is a topic that you struggled with in our last semester or in our last unit. Make sure that you chat with me about getting maybe some extra help, extra practice with that factoring stuff, so that's not going away. The new part for today was setting each of our factors equal to 0, but that's also pretty similar to what we did in our last unit when we found x-intercepts, okay? And when we looked at solving by graphing, we even said, if I'm setting it equal to 0 and looking at the graph, that means that we're looking for x-intercepts. So that's essentially what we're finding here when we're solving by factoring. Questions for me on page 14. Okay, that's it in our notes packet for today. For the remainder of class, you have an assignment on built map. It's some more practice with the same material.